Hello everybody, today we are going to create a basic RAG agentic AI system, and we are going to be this session will be very basic. So if you don't know about anything about RAG or how to create RAG system, then watch this session and definitely follow the code to understand, and I will explain you each and every term that I'm going to use and that I'm going to work on. Okay, so let's start with it. So as I told you earlier also in all my videos, that you just have to see the video, follow what I'm following, and you will see the results. Okay, so don't do I know, like, creating an environment and managing all this stuff is very tough. I have also been through that, so I will give you the simplest way how to do this. And we are using UV package manager. As I've told you earlier also, UV package manager is very fast and lightweight. As you can see, as when you do pip install and you do UV pip install, there will be the UV package manager will install all your packages quite fast. So let's see. So first of all, come to your project folder. Then the first thing you have to do is to you open your terminal, and you have to write pip install UV. Now since in my system it has already been installed, so it will show requirement already satisfied, but you have to do this for if you are watching it and you haven't done it, then you have to do this. Okay, now the next thing we do is we create a virtual environment. So for that we write UV init, and then we write UV venv. This creates a virtual environment. So we have got our virtual environment, and to activate virtual environment we have to write venv slash scripts slash activate. So our virtual environment has been activated. Now what are the things that are required? The very first thing is we require a requirement.txt folder, and we require a we require .env folder also. So .env folder is okay. So the .env folder will consist of all our environment variables. And what are the environment variables we are going to use? See, very first thing is we are going to use an LLM. So for that LLM you require a requirement.txt folder, the very first thing. The second thing that you require in requirement.txt is Hugging Face API. So we are going to use Hugging Face All Mini LM as an embedding model, since ChatGPT embedding model is requires some pricing. So if you want to do it, you can get the API. If you have the API of ChatGPT embedding model, you can integrate it as well. But we are going to use the Hugging Face embedding model. So let's focus on the Hugging Face embedding model. So let's first of all we have to create a requirement.txt folder. Requirements.txt MENTS requirements.txt. Okay, so we have a requirement.txt folder. What are the things we require? First require LangChain. Okay, then we require LangChain core. Then we require LangChain OpenAI. Then we require LangChain Hugging Face, Hugging Face. Then we require ChromaDB, LangChain ChromaDB, and ChromaDB. Then we require LangChain Text Splitter, LangChain. I will tell you what is this. What is this? Text Splitter. Okay. We require LangChain community. We require python.env. The sentence transformer, very important. Sentence transformers, and then transforms. Okay, these are all requirement.txt we require in the requirement.txt. Now what we will run, UV pip install -r requirements me and the requirements.txt. Okay, So all the okay, no solution found when resolving dependencies because the LangChain OpenAI was not found in the package registry. Some mistake, I guess. Okay, it's LangChain. Let's install one more, that is IPy kernel. IPy kernel. Okay, now let's run it again. So mistake as LangChain Chroma DB. It's not Chroma, it's Chroma DB. It's not. It's just Chroma. I hope it will run. And we're installing all our packages. So briefing about what we're going to build in this. We're going to build a basic, rack system where we will have a txt folder in our folder system, file system, and then a txt file in our folder system. Then we will have the embedding model. We will use that embedding model to convert the text into embeddings, vector embeddings. And for that we require, firstly we have to split the text into multiple chunks, and for that we require recursive text splitter. And when I will work on this, I will explain you what is recursive text splitter and how, and what is the need of recursive text splitter. So let's start. Okay, so we have done all our settings. We require .env file, env.env. Okay, now I won't show you my .env file because of course for the obvious reasons. But what are the things that are required in .env file? The very first thing is you require a Hugging Face API, and the next thing that you require is an API for any LLM. I will show you how to generate these APIs, so don't worry. Not in this video, but in some other video. So I'll do the configuration. We will create our first basic rack system, basic rag .ipynb. We'll go to this file and we'll create the very first thing is 1 plus 1. I run this so that I can initiate my kernel. As you can see, our kernel is working. Now we'll start with some imports. So what are the things that we import? The very first thing is we import OS, then we import from .env, import load.env. Okay, then we import very few one of the most important things that are from LangChain core dot prompts LangChain. Okay, some LangChain LangChain prompts import chat prompt template. What is this chat prompt template? Before going further, I want to explain you what is this chat prompt template. Move further, I want to explain you what is chat prompt template. The chat prompt template acts like a message blueprint. Okay, message blueprint is basically how the messages are written dynamically. For example, the user questions and the retrieve context are to be included in the prompt that is going to be given to the LLM. For that we require chat prompt template. The next thing we are going to import is str output parser. I will tell you what is the need of this. From LangChain and core dot output parser, I guess output parsers, import str output parser. Okay, then we require output parser is basically used to process, or you can say structure the output of the LLM, that is used for structuring the output of the LLM. Then we require the runnable pass through. So we require from LangChain core dot runnables, import runnable pass through I guess it will be here. Okay, now what is this runnable pass through? Runnable pass through is basically used when you want to carry something from one stage to another stage. So as it is, So if I'm using a certain prompt and I want to like a question given by the user, now I want the question to go from one state to the other state without any change in the question. That is produced in LangChain through runnable pass-through, and I'll show you how to do this. I'll show you with an example. Okay, then we come from LangChain community will import a document loader. Document loaders import text. I think it's text loader. Text. No suggestions. It's text loader. Okay, now we text loader because we are using a txt file we are loading a txt file. That's why we are using a text loader. Now the next thing we are going to import is from LangChain. I'll show you what it is. From LangChain Text Splitter. LangChain Text Splitters import recursive text splitter. Recursive text splitter. Yeah, text splitter. And I will tell you what is this. Now we require Hugging Face from LangChain Hugging Face. LangChain Hugging Face import Hugging Face. Uh, Hugging Face embedding. We require embedding. The next thing we going to import is ChromaDB. That is from LangChain Chroma. Import Chroma. Okay, wait a minute. The next thing that we're going to import is OpenAI. From LangChain OpenAI import chat OpenAI, and then we're going to run this cell. Okay, we haven't run this cell. To run this cell, so all the imports will going to take place. I want to tell you about the recursive text splitter. Why we are using recursive text splitter? Actually, see, when you're using a rack system and you're providing that rack system to your LLM, you don't provide the complete documentation to the LLM, because imagine there's so much documentation. If you're talking about a company and a company has some regulations and rules, the regulations rules could be huge regulations, and as per continents, as per specific locations, there could be different rules and regulations. Now if you're providing that rules and regulation for the LLM as a context, then the LLM won't be able to understand it, because or the context window will exhaust, or it won't be able to produce the coherent responses, or contextually aware responses, semantically closer responses. So what we do is to we recursively split the characters. So if we have a document, we split the document in recursively. Why when I say recursively, I want to mean that we will find, we will provide you we will provide us some chunk size. Okay, and for to split that document according to the chunk size, like if you take chunk size to be 1000, so now the recursive text splitter will split the document according to the chunk size. So it will find, first it will find a double slashes, then single slash, then commas, commas, and all these it will find and recursively split the text. So that is why I use recursive text splitter. Now what is the benefit of recursive text splitter? The very first benefit of recursive text splitter is metadata management. Actually, recursive text splitter is actually dividing the text into certain sections. Okay, and this helps to create a contextually aware a rack system. So it is very important to use recursive text splitter. There are other text splitting methods as well. I'll make the video about this in some of the other videos, so you can go and read about it. Recursive text splitter. Recursive text splitter is very good and very important when you're using with the rack system. It is one of those concepts that you will use every now and then when using a rack system, so focus on this. Now the next thing that we are going to is to load our LLM. Now to load our LLM, I will show you my LLM. So this is my LLM. I have defined my LLM. You can use your own LLM, whichever API you're using, and we'll define our LLM. So this part of code is anywhere you can change this part of code with any other LLM. Okay, that is what I love about LangChain, is that it gives you, vendor locking is not there in LangChain, so you don't have to stick to uh, some uh, uh, some other LLM. You can move from one LLM to the other LLM, and the benefit is that sometimes certain LLMs provide response to certain things quite well, and then some other to some other LLM. So you vendor locking is not there. So now we have done this. Now we'll come to the core part. Once we have decided to create this, we are going to create a text file. Okay, so let's create a text. We'll name it as knowledge knowledge.txt, and we'll paste some of the knowledge, and this will be a synthetic data. Okay, synthetic some text. Okay, this won't be something that you can find on internet, so I'm just creating synthetic data so that you understand that it is working. Okay, let me have the text. So as you can see, we have created a synthetic data about this person called Jonathan. John Miles is a man defined by a meticulous and aspirational love for James Bond, passion that borders on lifestyle emulation. By day, John is 44-year-old risk analyst in Chicago, a professional steeped in data, predictability, and all that. So it's just a fragmented data, synthetic data. You won't find any kind of anything about this person. It's just the data I've created so that you understand that how the rack system works. The next thing we are going to do is to come to the uh, basic IPv4 folder, and then we first of all we load this file. So we create loader is equal to text loader, and we give this path. Okay, so copy path and we'll give the path. So you don't have to give all this, you just have to give this. Okay, and if you run this, the loader has been loaded this. So loader, you see loader, so you'll see the LangChain document loader dot uh, page content. Loader dot content is like something like that, content load. Okay, loader dot load. If you run this, it will show. Okay, so this, if you just do loader.load, it will be a document, and then you can see metadata. Now this is very important. Why we require metadata? Metadata is very useful because it helps the LLM to be contextually aware. Because, and currently if you see, the rack system is basically do semantic similarity. Now semantic, the problem is sorry, not semantic similarity, it is similarity search. The problem with similarity search I'm really sorry. The problem with similarity search is that when you actually when you're working in an environment and you do similarity search, what is this similarity search? Is just cos. Okay, cos theta. So when you in our, in 11th and 12th we have studied about the a dot b is equal to ab cos theta, and that cos theta is a dot b. The higher the value of cos theta, the more aligned the two systems are, the two vectors are. So we produce a dot product between two vectors, and then we get the results. So currently the LLM do this, but this is not the right way, because no matter how, see, when you do similarity search, there is no context that is involved. Hence we should focus more on semantic similarity rather than on similarity search. So that is why the metadata management is very important. Then you have a metadata about knowledge.txt, it's a file, and then you have a page content is Jonathan John Miles, and the thing that I've shown you. Now that we have loaded the, now we will split. So splitter is equal to recursive text splitter. And what are we going to pass in here is that first of all we'll pass the chunk size. Okay, chunk size equal to chunk size, let's take chunk size to be 1000, and we'll take the chunk overlap is, okay, so let me show you chunk overlap. I write 200. Now what is this chunk size and chunk overlap? Now chunk size is how in how many chunk I want to separate these documents, and chunk overlap is in between two chunk, how many letters can overlap. Okay, so this is the chunk size and chunk overlap. The next we will, we'll just create the document. Docs is equal to splitter, splitter dot splitter dot split documents. Okay, so you just have to split document and you'll part the document, that is loader. Oh, okay, no, we have to do this. Forget to pass loader dot load. Let it be document is equal to loader dot load, and we'll do document. Okay, so we'll, okay, some chunk overlap. There's some mistake, chunk size and 1000, and chunk overlap over overlap. Okay, so yeah, so we have the docs prepared, and you can see docs. So this is page, this is the document that is split, and you can see, you can read this, some overlapping is there, so go and read this. Okay, the next thing we are going to do is, and you can, this knowledge.txt file, you can create this knowledge.txt file according to your needs. You don't have to copy this, though if you want I can provide you, but it's no need for that. You can, prepare any kind of secondary data from internet. Now we'll create the we'll initialize our embedding. So embedding is equal to embedding embedding is equal to Hugging Face embedding. And which model we are going to use? Model name. So you can search, you can go and find it. It's a sentence transformer. Okay, sentence transformer slash all mini LM L6 V2. So this is, I guess I have written everything right. The spelling mistake, I'm just checking. Okay, so embedding has been initialized. Now we'll create our vector store. So we can store vector store is equal to chroma dot from documents we'll pass that our document and the embedding. So we'll pass the splitted document, and then we'll pass the embedding. So embedding is equal to embedding. Okay, now we'll pass these to anything else. Okay, so we pass a directory, because directory is important where it will store. So okay, something wrong. Docs and embedding, then you have to persist directory is equal to, and in the same dot let's be chroma db. Okay, so this is what we will create. Something wrong. Vector store, we create a vector store. Now we will create a retriever is actually callable, and which we will use to take our documents, how many how many documents we require. So retriever is equal to vector store dot as retriever, and we'll pass the how many documents we require. So we require search. I forget what is the, it's like works, and then we pass it as /k as dictionary 3. So we require three documents that match our size. Okay, so and then we have created this LLM we have defined. Now the next thing that we're going to do is to create a prompt. Now prompt is important. Okay, I'll show you. Prompt is equal to chat prompt template and dot from template. So AI assistant use the following content to answer the questions. Now we'll pass the context. Context and we'll pass the question as question. So we'll pass these two things to the prompt. Give a concise and factual answer. ANSWER. Factual answer. Okay, now we'll initialize the chat prompt template. Now the next thing we are going to build is we are going to build a LangChain pipeline using LangChain Expression Language. Now just use this, and LangChain Expression Language is basically used to create a pipeline. Okay, I'll show you how to create it, and it is very easy. You'll understand it. So we're going to create rack chain is equal to. Okay, now very important thing, what we require, the very first thing is required by dictionary, and in the dictionary we're going to pass context. Context is the spelling correct? Yes, context. And we're going to call retriever. Okay, we're going to call the retriever, this retriever, and then we are going to pass the this we okay, so this line represents that what is the next thing that going to happen after this. So we're going to create a lambda function. So lambda function, I'll show you why we are creating this lambda function. Okay, so let me first write it, and then I'll show you what we're going to do. It's page content for something wrong in docs. Okay, so we have written this. Okay, so this is the first thing, then question QUE question is question enable pass through. Okay, now I will explain you this. See, the rack chain will take one thing, and that is the question, and the context will be generated from retriever. Retriever will provide all the context, and then the lambda function, what this lambda function is doing is actually parsing through all the documents, and what the next thing that is doing is to carrying those documents and adding them with double slash. Okay, so this is how it is joined, the two documents are joined, and then runnable pass through is, as I told you, the question that the rack chain will take, and it will carry that to the next step. Okay, this is the first thing, then we'll pass it to pass to prompt. Okay, pass it to prompt. The next thing will come is prompt. The next thing that will come is of course our LLM, because we have to generate this, and the next thing is going to happen is str output parser. Okay, str output parser, as I told you, is used to parse the LLM response, and this will help to generate structure the response. Now let's query this. Query is equal to, let's query something. Rack chain rack chain dot invoke. I guess invoke should work in here. Invoke who is John. Okay, let's run this. and we'll print. Okay, so we did some mistake. So actually here we are going to get some list of documents, so that is why we have to create this list. So change this according to this, and then runnable pass through should be passed in like this, and then this comma. You can run this, and then you can again run query, and then query will print query. Okay, John Miles is a 44-year old risk analyst from Chicago, and all this is John is the fan of which fictional character. So let's run the query again, and then we'll run this. John is fan of James Bond, and is the same thing that we read in here. So thank you. This is a very basic rack system that we have created, and keep learning.